Video, I want to talk a little bit about the changes in the way we do statistical analysis over the past 40 years or so. In the 60s, 70s, and 80s, statistical analysis was done primarily with mainframe computers. So users submitted commands or code to a central computer, and the computer would come back with the means or variances or regression analyses that were coded. The desktop computer changed everything. When the first PCs started showing up in the early 80s and the first Macintosh, I think, was 1984, then people started being able to do statistical analysis right on their desktops. And one critical development was the innovation of the graphical user interface that Macintosh pioneered. So people could do analyses instead of having to write lines of code. They could simply go up to drop-down menus and choose mean or choose analysis of variance, whatever they wanted to do. So it made statistical analysis a lot easier. But one of the problems with that sort of approach is that, in a sense, you are doing it blindly because you don't really know what the algorithm is that's used to calculate the regression equation or the analysis of variance. So it's a little bit of faith is that the analysis that is being done is in fact the proper one. So what has happened, interestingly, in the last 15 years or so is a reversion to the command-driven approach. And the reason for that is twofold. One is that by writing out the commands yourself, you know what the algorithms are, you know what the calculations are, so there's not any uncertainty about that, which is the case when you use drop-down menus in graphical user interface-based programs. And the other advantage of writing lots of code is that you can share your code with coworkers, with other researchers in other parts of the world who might want to use your particular approach or maybe want to reanalyze your data in a different way. I think that most of you have used Stata before, and Stata is interesting because it is, in a sense, a hybrid between the two. It has lots of drop-down menus, as you know, up above, so you can do much of your analysis there. But it also has a line for commands down here. And let's just do a simple example. What I've done is to load a data set of my own. This is on the arrival date of migratory breeding birds in Maine. So you can see the different variables here, and I've got about 3,000 records in this particular data set. But if I wanted to calculate the mean arrival date, so I'm going to use day of the year, so 100 would be April the 10th, 31 would be January 31st, and so forth. Let's say that I just wanted to calculate what is the average arrival date for all the birds in Maine. So what I would do is just to go up to the stats drop-down menu and just come across until I get to summary stats, and I want to calculate day of the year. Oops. That's what we want right there. Don't really care about biophysical region. So I'm just going to say OK, and I've got my value there. Well, of course, this value doesn't mean a whole lot because it's the arrival date of all the 105 birds in the data set all combined. But I'm just doing this as an example. So what we were able to do is to generate the mean and the standard deviation, the maximum and minimum, and so forth. But you'll notice that whenever we did the command using the drop-down menu, Stata also generated a command. And so we can see that that was summarized DOI. And I could click on that, and I could, in fact, modify it. So if I wanted to calculate what is the average NAO index, I could just do that, writing it in as a command, and then I get the value like that. So with Stata, what you can do is to either have a command-driven analysis, or you can use the drop-down menu. But over the past 5 years, R has skyrocketed. It is now the most used statistical analysis program in North America, bypassing SAS and Stata and SPSS, a very popular software package that's used by psychologists in particular. Why is that the case? Well, there are two reasons. One is the reason we've already talked about, which is that a totally command-driven approach means that you can share, that you can develop new code, that you can analyze other people's data, knowing exactly what they did. And the second reason is related to the first, and that is that it's open source. That is, it's free. So anyone can download a copy of R. And R is available for the Macintosh, for Windows operating systems, also for Unix. So most any user can download a copy to her or his desktop or laptop computer. But what I'm going to do is just to introduce you briefly to R and show you how daunting and clunky it is, and we have a way around this. But when you open up R, you see something that looks like this. You just see an R console. We look at the drop-down menus across the top, and none of them seem particularly related to analysis. So it's a bit of software here that has a fairly steep learning curve. So it's not something that's intuitively obvious how you go about doing that. But what I'm going to do is just to run through a few R commands for you. I don't really care if you follow along with what we're doing exactly, but I just want to show you how R works. And by the way, every time R comes out with a new version, they give it a cool name. So the current version is Frisbee Sailing. So that's pretty cool. Anyway, what I'm going to do is to open up a new document, and that's going to show up over here. And this document is where I'm going to enter my code. This area here is called the console, and that's where the results are going to be shown. And all of this is just material or messages that appear right when you log on. So we can get rid of that. So we'll do that. Now in R, there are lots of built-in data sets. So let's take advantage of the fact that there are built-in data sets, and what I'm going to do is to call up this data set that has data on cars. And so I have loaded that into R, and I can take a look at the first few lines of the data set. So do that. And you see that I've got these different kinds of cars here, and it gives the miles per gallon and the number of cylinders and the engine displacement and so forth. So, and what I might want to do is to just do a little analysis. So what I might think is that maybe there's a relationship between miles per gallon and the displacement of the engine. That engines with bigger displacement should get poorer mileage. So what we can do is to ask, well, is that in fact the case? So what I'm going to do is a quick little plot here. And so what I'm going to do is to say miles per gallon and displacement. And say, go ahead, give me that. And there's a perfectly nice little plot, but you can see it just popped up in the middle of things. And so now I've got these three different plots that are all over each other. So it gets pretty messy. And it doesn't take long when you are in an R session for you to generate tons of windows. And so trying to keep your figure out exactly where you are is pretty daunting. One of the nice things about the quartz here is that it in fact will allow you to scroll through previous ones, so you're not going to generate huge numbers of figures. But just as an example, let's go back into our console here, and let's say that we see that there's an interesting relationship here. So let's say that we want to do a regression analysis on that. So we're going to call this. I'm going to call my regression analysis So I generated my regression analysis. It ran. It didn't give me any problem there. So what I can do is just to say, I've given this what's called an object. And what I did here was to ask R to tell me what the intercept, So that's the b, and then this is the m. So the equation for this line would be y equals 0.0042 times displacement plus 29.599 should equal the miles per gallon in this particular analysis. And because I saved the analysis, what I can do is to look at various aspects of the regression analysis to make sure that I'm meeting all the requirements. So what I'm going to do is to plot, and you can see that it says hit to see the next plot. So I'm going to hit return here. You can see how this gets complicated because you have to go over here to hit return. But what this is going to do is to show the residuals. Ideally, you want to see this line here be straight. You want the variation above and below the line to be pretty similar all throughout the range of values from 10 miles per gallon up to 25 miles per gallon. So there's a bit of a problem here, but we can go on, and there are other analyses we can do as well. This is testing for normality, and ideally these values should appear straight, and they don't. So you got a little bit of a problem with meeting the requirements of regression analysis here. But what we can do is to go back, oops, click on this. What we can do is to go, oops, you go back and we can see the previous diagrams. But you still often end up with many different windows open at once, and so it becomes pretty clunky. And you know, if you didn't have any training, you wouldn't really know what to do next when you're working with R. So we're not going to use the R interface anymore. It turns out that some people a few years ago developed a front end for R that's called R Studio, and organizes things wonderfully. We're going to be using RStudio from now, from henceforth, and I think you will find that it makes things a whole lot easier and a whole lot more intuitive. So what you should do is to download both R and RStudio onto your computer, and you'll open R one time, and then that will interface with RStudio, and then after that you don't really have to have R anymore. You still need the application there because it's going to be run through RStudio, but it will become much easier for you to use RStudio to do your analyses.